Hello everybody. Today we're going to do another part of this series where we try to implement the logs interpreter. Up to the last video, what we have done here is trying to debug the garbage compact function. What seems to happen in this compact garbage function is that we seem to be missing out some parts such that our function chunk is not being pointed to the correct thing after we compact our garbage. Well, it looks like we are trying to compact our function object. The value array inside seems like it's not being compacted or marked as used. Now let's look at the code to figure out if that's the case. This looking at the trace under mark compiler roots at compiler 977, we can start our trace from there. (997) we try to mark our function object. With inside our, let's take a look at our function object. Compiler, function object is a object function, and inside here there's a name. Let's check whether we did mark that name. Checking the actual implementation and mark object 0. We didn't seem to be marking the function type. Let's take a look at what this is. Free object. We do it during our blacken object pass. We do mark the name. Let's look at the definition. Doesn't continue. is actually used in the blackened object. Let's check the implementation for mark array. We're actually just swapping the values here. Why did not swap then? We actually do swap it. Do we mark this array as being used? Where do we mark the stuff as being used? In garbage compact, we have a compact compute. And what does this do? You check whether it's used. Basically, this is to do defrag. So at this point, all the data used would have to be set and subsequently freed. So question then, is it actually freed? This compiler function over here, is it actually freed? Okay, we actually go in and say that we want we do for everything. So what's the problem here? We seem to be moving to a wrong address. Let's try running it again. Starting from the bug. Somehow everything worked. I want to check the compiler in this case. Function, a chunk, values, constant. Constant is a struct that has a pointer values. Let's watch the whole thing. Run the function again. I set unreachable to capacity 0. Pretty reasonable. Capacity 8. Growing the array, initializing the array. We are trying to write something new inside now. We have updated so that we now point to this particular array here. Adding one more constant. Total of 2 constant. Now let's check the enclosing. Let's typecast it to check. Count of 2. Let's fix the compiler location as well. That's right. Now this is altered. This is wrong. But a good pickle rank, right? We haven't shifted it yet. Clear wrong now. But this address might be wrong now, right? Let's check whether this is wrong too. We never changed the enclosing. That's the error. We also need to check the enclosing. Make sure that it gets pointed to the right place. But does this actually work? Let's check the implementation of compiler. It's not really an object. What will happen when I pass the object through it? Will it run successfully? Is the compiler object part of the memory that was allocated in the buffer? No, it's not. It's not setting up. It's not yet setting up. Compiler is a struct. It's not in the buffer space. It's in the heap. Creating a new compiler. How do we know that we have passed all the different compilers? For that, let's print some stuff. Let's print the address of the compiler in question that we are running. Building. Running the file. Running for the test file. There's an error. I want to watch. Current function chunk constants. Let's print it first to double check. And this is indeed the erroneous one. Run the file again. Beginning. Init compiler expected. Setting up the new array as expected. Adding value. Adding value, reasonable. Adding 2 values, reasonable so far. Compact swap, I see a lot of marking key. I don't quite. I also see marking compiler. So far we have 2 compilers. Let's make the words a bit smaller. Okay, so then we can scan through. 2 marking compilers here. This is where it messed up. Why? What are they trying to do? The memory that is pointing to is being moved. For now, because we haven't updated the constant. Let's check whether we actually update array. Mark array. Mark array. Value array is a struct. Value array is a struct. And is this allocated in the... Let's take a look. It's a struct that has a pointer that points to something that's in the buffer, which is okay. Where does our dig lead us? It shows us that is this still valid? This is not valid anymore. Current function is not valid anymore. Which is okay. It's pointing to D30, D80. It's somewhere on the heap. Casting it to a compiler star. We can also see the function that it points to. All 5s, A98. It points to the same thing. Points to the same thing. Seems like the function is not getting caught. Let's check. Seems like the address did change. but we are not shifting it. Let's check whether we are doing it right. We did mark roots. Question is, where is marked compound roots caught? And how come this is not changing the value of the function? It should have changed. Let's make it a bit more explicit. This marking 0, this marking 1. Let's kill the function, do it again. Now we run. What is supposed to show? Marking 0, marking 1. None of these have changed. None of these have changed. Let's print something else as well. In memory.c, we have a variable is compact swapped. Let's try to print that as well. Now we build. Running the closure test file. Should have changed. Let's see why it doesn't. Let's see what it's supposed to be. Do again. Logs. Run the closure test file. Somehow, this is returning the same thing. Was there any compact done? Let's run it in a usual way. All these have no changes. There's no compute. Was there any compacting done? Yeah, there's some compacting done. And we see that the value did change, which is expected. It's okay. We shifted from one location to something that is before. CB8, B8, CB878. That's shifting forward. It's okay. It's reasonable. So why is it running to a seg fault? This compiler, is this the compiler? FDF. C9. Let's try to get this compiler. Function 890 chunk constants. Let's get this address. Not this one. Let's try this. Function chunk constant. Who used this? And why is it gone? This is altered, which is wrong. Let's watch this as we run from the beginning. We check, it's using the same address. Initted. Someone shifted it. It's a compact move. We haven't swapped our address yet. Continue. Now this is something weird. We're still running compact swap. What's the change here? Address of our function, that's the change. You're pointing to the right stuff now. Initializing, setting some stuff. suddenly there's a capacity of 3. We move again. But here, somehow, we never set the values. In growing the array, we seem to forget to set the values correctly. Is this correct? I go in, I mark out the stuff I saw, I move stuff. Right, not yet done. I move stuff, I set again, I just mark it as I saw something. Right. Then I forgot to set it. So what's happening here? Running a test from beginning. Let's check again. I grow the array. Something shifted. This basically shifted to the right place. There's a resize done. After resize, it seems to give a boo-boo value. What's going on here? How come my resize give me a value index of 0? CD8. That's the array in question. What's the old cap? 0. Capacity 8. Let's run this to see what is returned. Looks like I don't have the symbol grow array. Let's look at what grow array is. It's in memory.h. Type. Type pointer count 0, count 1. Array capacity value 0 value array values. I can run it, but it doesn't give me the correct value. Let's see where grow array is used. It looks like I didn't manage to correctly set the value here. Value.c array values. In the resize, something went wrong. Let's print something to check that we're on the right path. Before resize, I have O cap. And array values. I print both. Resize 1, resize 0. I have a new cat. And array 0 as well. Before running, let's build it. Now I'll run the same file. Right. We want to put something in question up to the test. We want to watch this particular expression. Running the test again. Complexity 0, that looks right. That's in compact move, still correct. Still correct. 0, 0, everything looks right. Resize value. Right, this is printing resize 0, 0. I did some moving and looks like it points to the right stuff now. But the whole thing is pointed away. What is actually happening? We are doing the writing in the wrong order. Let me illustrate. Why do I say that? So what happened here? We pointed we are pointing at the O location step 1 during garbage compact Step 1, we are pointing at the wrong location. Step 2, we updated to the updated the old locations value to the we are pointing at the old chunk. We are pointing at the old function. Updates old functions value to new value array address. Step 3, updated function pointer to new function address with the old value array address. Therefore, we don't see the new value array address. We need to make sure that the function pointer is correct before we do the value arrays address update. Now that we found the bug, we're going to stop here for this particular part. Right, so let's go through a bit of what we have found and the reason of why it's throwing an error. So what's the observation here? The observation here is that for some reason, after a garbage compact, our compiler's function with a value array pointer that seems to have some error where the address is pointing to 0 when clearly the capacity is 8. So what's going on there? We checked the code. We thought whether... Okay, so first we checked. Is the function updated? It's updated. Right? Is the value array pointer updated? It's updated too. Then the question then becomes, why is it that the pointer here is not updated? And the reason is only because when we update the value array, we're actually updating the value array of the old function pointer. So what's going on here? Right, with the when we update the value array address in the old part of the memory, it gets updated, everything seems to work. But when we later update the function pointer to point to the new location of the function object, the address is not there. So we have to make sure that the value address updating, or all pointers within pointers address updating, is done in the correct order. We have to update everything on the outside first, make sure everything is shifted, then start doing the replacement of the things inside. Now with that, in the next session we'll see how to fix this. Thank you for staying so far. Goodbye.